So, wanted to start this video with, in the topics page, if you go to Unit 7 right here, you see that there are Algebra 1 May Camp instructions. I will also send this to you in an email. So here's how this goes. And please go back. There we go. And then this is basically your packet. Those are the notes in the middle, the homework assignment on the left, and that's basically what we're going to do. So these videos are going to be focused on the notes here, and we're going to go through and do these. And Ollie's here in class to do some of these notes with us. So first of all, we're going to go through and just do a reminder on prime factorization. This is an important piece. So prime factorization and perfect squares. So remember with primes, you can break it down into using any two numbers. You could start with 8 and 10. It doesn't really matter. But I like to just go down with these. And what we have is we have 1, 2, 3, 4 twos. That is 2 to the 4th times 5. You could also write it as 2 times 2 times 2 times 2 times 5. But when we do 245, this is not divisible by 2. But if you use a calculator, you'll find that this is 5 times 49. And 49 is 7 times 7. So that is 5 times 7 times 7, or 5 times 7 squared. 448. 2 and 224, 2 and 112, 2 and 56, 2 and 28, 2 and 14, and 2 and 7. So how many twos do I have there? Ollie, tell me the answer to that. 6 of them, thank you, while I'm resizing this. So that would be 2 to the 6th times 7. And then 648, we go 2 and 324, 2 and 162, 2 and 81, and then that's 3 and 27, 3 and 9, 3 and 3. So this is 2 to the 3rd times 3 to the 4th. So that's the reminder on prime factorizations. And then perfect squares. All right, Ollie, I want you to hit me. How far can you go with perfect squares? 1 squared.
Yeah.
What is it?
1 squared is 1.
1. 2 squared?
4, 9, 16, 25. 36, 49, 64, 81, 100. 121, 144.
169 and 196. I always remember that because they're like backwards of each other. And then you got 225. And then you go, what's 20 squared?
20 squared should be
400. So 16 squared is 256, 289, 324, and 361. Now, these are important because we're going to start talking about square roots. So what is a square root? When I write the square root of A is equal to B, what does a square root mean? What that means is what number squared gives you the number. So what that means is when I ask, so that means that if the square root of A is B, that means that B squared is equal to A. So if I ask, what is the square root of 36? You know what that is? What is it?
That is
6. Why? Because Yes. So when I ask you for a square root, what you can do is you can go to this list, say, here's 36. What squared gives me that? It's 6. Okay? So we'll do a couple of these down here. But we're going to do some vocabulary on this. When I write this right here, square root of a, what we have is two things. This is called a radical. And the thing that's underneath is called the radicand. Be a good hangman word. So essentially what we can do is we use this rule that the square root of a squared is equal to a. So in other words, what that means is we have a pair of a's, we can pull out a group of two factors can come out. So when you have the square root of 81, the square root of 81 is the square root of 9 squared, which is 9. So there's this like in-between step. Okay?
Can I just solve 81 to 9?
So yes, you can, but it's really important to understand what's going on because it's going to get more complicated. So you have to understand how we go from over here to, like, you have to understand this step so we can build on it, essentially, okay? So, but these are really easy. You're basically finding these up in the list up there. So the square root of 169, that is also known as the square root of 13 squared, which is 13.
Wait, it's 13? I thought it was 14. Oh, no, I messed them up.
So square root of 361, well, 361 is 19 squared, so that's 19. Square root of 196 is the square root of 14 squared is 14, and square root of 225, that is the square root of 15 squared, which is 15. Okay, so that's just a basic, here's what a square root is, okay? But like we do with a lot of this stuff, we're redefining it so we can build on it.
Can you zoom back in on the last column of squares?
Right here?
Yeah.
I'll give you the last two. All right. So now what we're going to do is look at properties of square roots so that we can build on this. So in order to simplify radicals, we're going to be using the product rule for radical expression. And what that means is that when you have the square root of a times b, this can be written as the square root of a times the square root of b. So if you have things multiplied together, each individual factor can get its own square root. That's going to be a really useful tool. By the way, the same thing is true for division. You won't see this as much this year, but we'll definitely get into this in Algebra 2. Now, what are the rules for a fully simplified radical expression? There are two things. Number one is the radicand. What is the radicand again?
It's the bottom one.
It's the number under the radical, okay? So radicand has no factor that is a perfect square. So if you have the square root of 9, you can't leave it as square root of 9, you have to simplify it to 3. But furthermore, if you have the square root of 18, you can't leave it square root of 18 because it has 9 as a factor, which is a perfect square. So that's not simplified. We're going to talk about how to simplify that. And number two is, and we're not going to see this as much here in Algebra 1, but it's important to note when we're talking about this, is in a simplified radical expression, there are no radicals in the denominator. So if you violate either of these rules, it's not fully simplified. It's like a fraction, right? You don't write 4/8. You have to cancel out the common factor and reduce it to 1/2, right? Same thing goes here. So if you notice, all of these are the same as these, right?
So would I put, so if it was 2 to the 6th,
All right, so what I'm going to do is I'm going to copy this and bring it over here. Okay, so square root of 80 is also known as the square root of this. Square root of 245 is also the square root of, I'm going to take this one. Square root of 448 is the square root of this one. And square root of 648 is the square root of this. So basically, when you have a square root that you need to simplify, you have to get the prime factorization and think about the numbers that are in here, okay? Now, each of these things, so 2 to the 4th is, there's 4 2's, right? So what you're looking for is perfect squares, right? So I could also write this as 2 squared times 2 squared times 5.
that's perfect square.
So that's why I'm doing it, because we have this rule that the square root of a squared is equal to a. That's why I'm pulling out this, I'm doing the squares, right?
But is that divide there?
Not yet. Okay, so let me do one at a time. Sorry, I'm jumping ahead. So what this does is it allows us to take the square root of 80 and give each thing its own square root. Right? That's the product rule. When we have two things multiplied, each thing can get its own square root. So when I think of this, there's 4 2's. Each pair is going to get its own square root. And so what does this do? 2 times 2. The square root of 5 stays in there. And that is 4 times the square root of 5. Okay? Same thing here. I'm going to put the square in front. I'm going to do square root of 7 squared times 5. This would be the square root of 7 squared times square root of 5, which is 7 square roots of 5. With this guy, each of these little things gets its own perfect square.
So it'd be 8 times the square root of 5.
Yeah, square root of 7 in this case. Now this one's a little trickier. So in this one, if I'm breaking this up with just squares, there's 3 2's, so there's a pair and one left over. But there's 2 pairs of 3's, okay? So if I rearrange that, I can write this as 2 squared times 3 squared times 3 squared times 2.
So that would be 6 times, it would be 18 to the
equals 2 times 3 times 3 times root 2 equals 18 root 2. Okay? Now, I talk a lot about how I show all of my work, but it's not necessarily the way that I do it, right? So let me talk about how I think of it now that we've learned how to do this. When I write this out, I know that each pair comes out as a 2. So we can kind of skip this. In here, there's 4 of them, right? 1, 2, 3, 4. There's 2 pairs, and so I can write this as 2 squared outside, okay? Same thing here. There's a pair of 7s that comes out as a single 7 out here, right? There's 3 pairs of 2, so that's going to come out as 2 cubed, which is 8. There's a pair of 2s and 2 pairs of 3s, so that's 2 times 3 times 3, which is 18. So you can skip some steps, but in these notes, I like to show all of these steps. So that's how you go about simplifying square roots. And at this point, you can go into the homework and simplify these guys. I guess there is one curveball I should point out. Maybe I'll do number 12 on the homework here, because that's a little different than what I did in the examples. So in number 12, it has a number out front. So for something like this, I would take what's under the square root, and I would do 216. We want to go down to the prime factorization. That's 108, 54, 27, 3 times 9, 3 and 3. So this 3 chills out here. But 216 is 2 cubed times 3 cubed, right? So when we think about this, there's 1 pair of 2s. So the 3 is still out here. Actually, let me demonstrate this by doing this with a different color. So the 3 is in blue and it's chilling out here, right? But then from here, I'm going to show all the steps, but you can think of it as a 2 and a 3 are coming out and a 2 and a 3 are left in, okay? So that's going to be 3 times out of here, we're going to get a 2 and a 3, and inside we're going to have a 2 times 3, right?
So basically you solve it normally and just leave
Yep. Right, and these come out, a pair comes out of the square root. So 2 times 3 times 3, this final answer is going to be 18 root 6. But let me show this step the way that I did it before. So 2 cubed is 2 squared times 2, and this is 3 squared times 3. And if we break that up, we get 3 times the square root. I'm going to put the squares in front, right? And so that gives us, this 3 is still chilling out here. Don't forget about him. 2 squared, 3 squared, 2 times 3. And so this, you can see how that comes down to this. The square root of 2 squared is 2, square root of 3 squared is 3. These 2 get put back under 1 radical, and we have, multiply these guys together, 18, multiply these guys together, 6. Okay, so that is the gist for this section. Good luck.